So today we'll discuss regarding top-down parsing. So top-down parsing is nothing but, so it can be viewed as the problem which you are going to construct of a parse tree for the given input string. So here the parsing is nothing but, so when you are constructing a tree, so in which way we are going to evaluate the given string. So here, so in top-down parsing, we are starting from the root and creating the nodes of the parse tree in preorder. So generally, so when you are constructing the tree, you may get different types of orders and it, like preorder, in order, post order. These are things which you are having. So here in top-down parsing, we are constructing the parse tree with the help of preorder. So here what we are doing is, you may construct the parse tree for a given grammar in different ways. So for example, here we have a grammar, we are supposed to construct a grammar for the expression id plus id into id. So this is the expression which we are having. So for this expression, we are supposed to construct the grammar. So and then after, once you constructed the grammar, then we can go to how to construct a parse tree. So when you observe here, the grammar which you are having, so the statement which you are having is id plus id equal to id. For this, we are going to construct the grammar. So e tends to t e dash and e dash tends to plus t dash epsilon, and t tends to f t dash tends to star f t dash and epsilon, and f tends to e or id. Here e in the sense expression, so t in the sense terminal. Okay, so and e dash is also one type of expression. So we may construct the grammar for the given expression. Once we are having the grammar, then we can go to construct the parse tree. For this grammar, whatever we are having, so for this the parse tree will be like this. So this is the top-down parse tree for the given expression id plus id into id. So here I am taking e expression. So e may be t e star. Again e, t may be f t dash and e dash, and then e tends to t f t dash, f in the sense id, and then e dash. So again t e t e dash f t dash id, t dash may be epsilon, and then e t f t dash id e, then e dash may be plus t e naught. Again I am going to expand this process. Okay, so again e dash plus t e dash, so t may be f t dash and f can be id, and then so f t dash id, t dash can be star f t dash so, and here id star f t dash, f can be id, and then f id star f t dash id, it may be epsilon. So like that we can construct the parse tree using top-down parsing. Means we are starting from top, so up to bottom we are taking, and this tree can be constructed with the help of this grammar. Whatever the grammar we are having, based on this grammar I am going to construct the parse tree. So here we are using some parsers to build the top-down parse tree. Here the first one is recursive descent parsing. So with the help of recursive descent parsing, so if you are having any issues with the top-down parse tree, so we can evaluate here. So here we are using one procedure to construct the top-down parser, so that is called recursive descent parsing. So means we are using recursive techniques. So here the recursive descent parsers simply try to build a top-down parse tree, it means without any complication. So we are going to build the tree, and it will be better if we always know the correct action to take. So when you are having the grammar, you may get different options. And for example, here you may be apply te dash. So e dash can be plus t dash or epsilon also. T can be ft dash. T dash can be star ft dash or epsilon also. F can be e or id. So which one you supposed to choose? Whether, for example, if you are having e dash, whether you supposed to choose this one or this one. That is, you people only decide based on the given expression. So, and that's we are saying it would be better to if always know the correct action to take. So, and it would be better to avoid recursive procedures calls during the parsing. So, maximum try to avoid the recursive procedures. Means recursive means the calling by itself. So the procedure calling by itself, that we call it as a recursive. And for this recursive descent parsing, we are having one algorithm. So this is an algorithm. So it is for non-terminal in top-down parser. So in grammar, we may find the terminals and non-terminals. And this is an algorithm to go with non-terminals. Here I am taking one procedure called A. So what I am doing is choose an A production. So A tends to some x1, x2, xk. So means in this grammar we are going to take E, the production with E and it. Okay. So whatever the production we are having, we are supposed to choose that one starting. And then for I equal to 1 to k, means here I am having up to k. So we are having up to k. So for I equal to 1 to k, if xi is a non-terminal, whatever I choose, x1 or x2 or x3 or x4 up to xk, if it is non-terminal, then I am going to call the procedure xi and I am going to call the procedure xi. Else if xi is equal to the current input symbol a, if the element is equals to a, then advance the input to the next symbol. So means I am omitting this symbol and I am choosing the next one and else error may rise. So this is a recursive descent parsing algorithm to construct the parser tree. So what I am doing is, so I am going to take one procedure and I am choosing one production. I am choosing one production and by taking all the input symbols. So I am keeping one loop up to n number of symbols whatever I am having. Here I am having k symbols, that's why I can for I equal to 1 to k. And I am checking whether is it non-terminal. Is it non-terminal? If it is non-terminal, then I am calling xi procedure. If it is a terminal, so if it is a terminal, then I am checking is it input symbol equal to a, means whatever the symbol I collected. Okay, if both are equal, then advance the input to the next symbol. I am going to choose the next symbol. If not equal, then I am getting error message, means the tree which I constructed is not equal to the expression which I chosen. Okay, so this is one of the way to recursive descent parsing algorithm to construct the parser tree. And next we are using first and follow. So there is a methods called first and follow and so this will be used to construct the bottom up and top down parser trees and so first and follow, these two are the methods, others we call it the functions also, which is helpful to construct top down or bottom up parser trees. So how we are going to construct? Here I am taking the grammar symbol and one symbol and I am calling the first method by passing the symbol. So it is the set of terminals that being all possible string derived from alpha. So alpha is nothing but all the possible terminals and whatever the terminals we are using in the given grammar that I am going to take. If alpha is epsilon, then epsilon is also in first of alpha. Means whatever the terminals you choose in, if epsilon is also in that, then we can add that one also. And the method will be like this. So first of symbol equal to first of t equal to first of f equal to id, comma or id. And first of e dash equal to plus epsilon. First of t equal to comma id, sorry, bracket comma id. So first of t dash వచ్చేసి it comes star epsilon first of f id. So here how we are going to calculate, that can be done with the help of the method and the first method. So now we'll discuss how it is going to work. So follow of a I am calling, so just a minute. So this is the process to compute and a. Okay, next we'll discuss follow. So follow is a non-terminal a, the set of terminals that can appear immediately to the right of a in some sentential form and a. So first method, what it is going to do is, it is going to start with an alpha and a. Okay, it is going to start with an alpha. Alpha is nothing but the set of terminals that begin all possible strings. So means here these things we can say, okay, e dash t dash f. So a set of grammar symbols alpha, the set of terminals that begins all possible strings derived from alpha and a. Okay, these all things comes under set alpha. Similarly, follow is a non-terminal a, the set of terminals that can appear immediately to the right of a in some sentential form. So if you chosen one non-terminal, so it is going to take the set of all terminals immediately after that one only. If I chosen a, after a whatever we got, that will pick up. Okay, so then dollar is also in follow a. Dollar is nothing but the end of the symbol and if you consider any string, so generally dollar will indicate end. Okay, that is also included in the given set. If I said e tends to t e dash, then power of e is nothing but, so whatever we are having, bracket close and dollar. If I said for this one, so follow of e dash, it will be follow of e equal to bracket dollar. Again follow of t equal to plus follow of e, plus follow of e will come, and it will be having set plus close bracket dollar. Then follow of t dash, it contains plus close bracket dollar. Follow of f contains star plus close bracket dollar. How we are going to find out? With the help of this algorithm we can process and it. So when you are going to compute the first alpha, it will be like this and it means here I got the, I mentioned all the things. Here I mentioned all the things. So this I got with the help of this method, and this one also computed. So here what I'm saying is, when I'm going to calculate first of alpha, so first I'm taking s as a terminal, then first of x equal to x. Otherwise, if it is not a terminal, then if x is epsilon, x epsilon is a production, add epsilon to first of x and if x tends to epsilon, if it is a production, then I'm going to add epsilon to first of x. And if x tends to y1 up to yk is a production, then place a in first of x if for some I. So a is in first of yi and y1 yk y minus 1 belongs to epsilon. So I'm checking whether a particular element is, if it is in between the things, then I'm going to add it and it. So I'm saying that if x tends to y1, then yk is a production, then place a in first of x if for some I, means for some I means for it may be y3 or y4 or y5. So a is in first of yi. If it is exist, a is in exist on that particular y5 or y6, and y1 to yi minus 1 is belongs to tends to epsilon if it contains epsilon. So simply I'm saying that I am adding one element to the set if it is exist in some way. So given first of x for all the single symbol x, so let first of x1 tends to xn equal to first of x1. If epsilon belongs to first of x1, then add first of x2 and so on. So like that we are following and then we got the strings. Similarly, follow also. So place dollar in the follow of s for S the start symbol. And if A tends to alpha B of beta, then first of beta minus epsilon is placed in follow of B and A. If A tends to alpha B beta, then means alpha, all the symbols which are having B, then beta. So then first of beta minus epsilon is placed in the follow of B. If there is a production like A tends to alpha B or A production or A, the production A tends to alpha B beta, where beta tends to epsilon, then everything in follow of A is in follow of B and A. So which we said here. So follow of E dash, it contains follow of E. Follow of T contains follow of E plus additionally, like that. So these two are the methods which will helpful to construct parse tree. Similarly, we are having LL1 grammars. So left recursive only. So LL1 grammar is also there. With the help of this one also we can construct parse trees only, top down parse tree. So here the predictive parsers, that is recursive descent parsers needing no backtracking, can be constructed for a class of grammars called LL1 only. So without backtracking, we can construct the parse tree using LL1 grammars. Backtracking is nothing but you are not supposed to move backside. When at the time of constructing the tree, you don't need to go to backside. And backside in the sense, assuming I am having one tree, so like this, I am taking some A, some B, some C, some D. So if I want to take additional id, so you don't need to check whether backside, means you don't need to go to back and check whether I am constructing the tree properly or not. That is called no backtracking method. You don't need to do like that with the help of LL1 grammars. So, and this LL1 grammars is rich enough to cover most programming constructs only. So most programming languages which will work with LL1 grammars only. So here I am going to work with LL1 grammars. It will be like this. So here the predictive parser algorithm can be applied to any grammar entity, but sometimes M might have multiply defined entries. It may having multiple entries and it. So for if else statement and left factoring, statement equal to if expression, statement opt else and it. So opt else is nothing but else statement or epsilon. So means it may having multiple entries will be there and it means nested entries will be there. At that situation, this predictive parser algorithm will not work properly. Means simply no backtracking. So here what I am saying is if expression statement opt else, if they have chosen else. Opt else is nothing but is having else statement, or else it may having epsilon also. So when we have opt else on the stack and else is the input, we have a choice of how to expand the opt else on it. So that can be done follow of opt else. So either rule is possible, whichever the rule is possible we can follow. So this opt else may be having else statement and it. That else statement we don't know what it is having. Okay, again it may having if statement also. So means nested is going to happen. So that nested can be avoided and here. So the predictive parsing construct for G leads to the parse table. So M dash without multiply defined entries, we say G is LL of 1 and A. So if the predictive parsing construction for the G means the grammar leads to the parse table without multiply defined entries, without multiple defined entries, then we can say that G is LL of 1. So one symbol for look ahead, leftmost derivation and left to right scan of the input. LL1 means so left to right scan of the input and leftmost derivation, and 1 it is a symbol for look ahead, means going to forward. So, and when we are using LL1 parser, we should follow some conditions. And first one is, if A tends to alpha or beta, means if the production rule is like this, then there does not exist a terminal A such that A belongs to first of alpha and A belongs to first of beta also. So at most one alpha and beta derive epsilon and if beta runs to epsilon, then first of alpha does not intersect with follow of beta. If beta turns to epsilon, then first of alpha does not intersect with follow of beta So means when you are using first and follow methods, so this process is going to execute in LL1. Next we are having non-recursive predictive parsing. Earlier we worked with recursive predictive parsing So with the help of recursive predictive parsing, so we constructed the top-down parse tree. Now we can work with non-recursive. Non-recursive means without any recursion process So here we are using these two statements. First one is, if x equal to a, then dollar. Dollar indicates the end of the string So the parser halts and announces successful completion of the parsing. If x equal to a and not equal to dollar means still process is there. Then the parser pops x off the stack and advances the input pointer to the next input symbol. So here it is assumed that if x is equal to a and it is equal to dollar, then we can say that the terminals are completed. Means whatever the elements we are going to construct the tree, it is completed. If it is not equal to dollar, means something is there. Then what I am doing is I am popping the x and moving the pointer to next input symbol. And next one is, if x is a non-terminal, if it is a non-terminal, the program construct entry of m of x comma a. It is going to construct one entry of m of x comma a of the parse table m So this entry will be either x production of a grammar or error entry, whatever it may be. It may be raise some errors also. At the time of constructing parse tree, you may get some errors also. So that error also can handle. So, and this is model for non-recursive predictive parser. So when I am going to process, first I am taking x. So sorry, this is expression a plus b dollar and a plus b means this is an expression and ended with dollar. So predictive parsing I am going to apply program or driver and parsing table entry m I am going to check it. So here x, y, z dollar I am taking. So this is the stack this is the stack. If element exists and it is not related to dollar, then I am going to pop x, then y, then z. If it is a dollar, then I am going to stop it. So these are the different ways to construct top-down parse trees. So here what we discussed is what is meant by top-down parse tree we discussed. Okay, so it will be used to construct the tree to solve a particular expression So the tree construction can be done with the help of the grammar. So first we are supposed to construct the grammar, then we can construct the tree. So for tree construction we are using different types of methods. One is called recursive descent parsing algorithm, then first and follow methods, and then so LL1, and then non-recursive predictive parsing. These are the techniques we can use to construct the parse tree.